All right, so this is my presentation for four-stroke engines. So let's get started. First, a little bit of an introduction. The four-stroke engine was invented by Alphonse Bodereau in 1862, and Nicholas Otto, 5 years later, actually invented the engine again and used it in the Paris Exposition. They both have patents, so the earlier one by Bodereau ended up uh, being preserved, and Otto's patent got thrown away. The engine uses gasoline and diesel, and the reason it's named a four-stroke engine is because it has four up and down motions. The first motion, when it goes down, is when the intake lets gas in. As you can see, there's this little mechanical um, rotating mechanism here. And in the second stroke, when the compressor goes up, the cylinder compresses the gas, which increases pressure and potential energy. And when it goes down, the gas is ignited, pushing the cylinder down. So if you notice in the third stroke, it goes down a little bit faster. That's because of the ignition and the gas expanding. And that causes the when the compressor goes up again, that causes the exhaust valve to open, which means the exhaust goes, and all of that energy that's stored goes this way out of the engine. Oh, and this is a real life example of a four stroke engine. A little bit more complicated, but the mechanisms are the same as the model up here. So, just to give you a little bit more of a visual, here is an animation. All right, so for design and use, the four stroke engine and its variations are used for many types of aircraft because the fuel is used for any mechanical step, so not a lot of fuel is wasted. That's really nice if you're trying to operate something with a large amount of fuel, like an aircraft. But they're really used in basic form. And if you think about it, that sort of makes sense because think of the like very antique automobiles that like have a constant sputtering to them. That's because the exhaust manifold doesn't have a constant outflow. It has an outflow every four strokes. Um, and uh, there are two main solutions to this, including a 6-degree four-stroke, which is essentially three four-stroke engines positioned in a triangle-like shape, pointing inwards, and a radial four-stroke, which is like that except it's in a circle. The radial four-stroke is really useful because it does have that constant outflow, and if it didn't have that constant outflow, um, something like commercial aircraft would have it wouldn't have a lot of altitude. Certainly not 31 to 38,000 feet, and it wouldn't be able to go 500 miles per hour, not at all. So, um, Yeah, as you can see, the rotating mechanism here, instead of instead of having instead of just rotating one time for each engine, it's using its rotating in the most efficient manner possible. It's going in a circle. So, and the exhaust manifolds are also going in a circle. So, next time you go on a plane or a car or anything, take note of the engine and you'll probably see some of these concepts in there. Um, and until then, thank you for watching and I'll see you next time.